Welcome to my session. This session is about how to cancel the watermark using active methods against the video streaming services. Let me give a brief introduction of myself. My name is Wang Kang. I work from Alibaba Group as a security researcher. And this is a joint work with Hui Yiqun. However, she's got some problems, so he didn't show up. It's a little pity. The outline of this talk will be, first I will give the essential technology background about the problem, the market, and the visible watermark and invisible watermark. Then after that, we will give some theoretical estimation about the two methods we are going to propose. The method number one is the pre-distortion method. The second is the post-process method. Then we will do a demo about how to do high precise logo extraction. After that, we will give a static experiment just to prove our concept. Then we will integrate our code with high real-time FFmpeg filter. Then some future work and related work will be discussed. So this is a landscape of currently video streaming services in China, because you can see there are dozens of services running. Actually, I get the list from a open source project called YouGet. It's pretty much similar to the YouTube-DL project. It's also a video download scripts, I think. Then I will give the watermark technology of the traditional methods, including the forensic, I think is the formal way to call the invisible watermark, which includes the transform domain methods, including wavelet-based or Fourier-based, and the compressed domain and spatial domain includes the least significant bits. You can hide information in LSB, or you can hide the information in blue channel, because the human eyes has less sensitivity about the blue channel, so you can hide something in the blue channel. This is a very simple but effective way, I think. From the other perspective of view of embedding and extracting method, they can be classified as additive and multiplicative methods. The most commonly used, the alpha channel method, I think, is the additive method. This, as you can see, is basically the wild west of the copyright currently we are facing, because the video are be reposted and forwarded again and again, and each of the services want to put their own watermark on it. So sometimes the watermarks will be placed twice. So this is a disaster for user experience, I think. So as a hacker, I want to do something to urge them to drop this ugly way. So maybe this is a historical tradition, because back in 17th century, the emperor of Qing dynasty, he has a bad loyal habit of place red stamps on all his collected arts. So even worse, when he finds something really interesting, he will put a comment. Well, what an emperor. So after that, the full life cycles of video, there are content side, like we have user-generated content, and the PGC is the professional-generated contents. And then they are passing through the VDM, which is called the Video Distribution Network, and comes to the playback endpoint, which includes browser and mobile and desktop. So from the content side, we want to do some pre-distortion to distorted watermark before uploading. Then the watermark can be added later, then be cancelled against the pre-distorted one. And the second, The other part is from the distribution network and the playback endpoint. We can add some post-process methods. So before we start to do anything, we want to make a few wishes, including we want to build a library that collects all the logos with high precision and with alpha channel information and with a size and position metadata. And we want to build a FFmpeg filter that is able to do 1, the pre-distortion method, and 2, do the post-process method with specified logo. And then we want to build a browser or a mobile app that can perform post methods against the watermark video. So we'll start by doing some theoretical estimation to get the probability of the recovery. Believe me, it's not that hard. It's simply mathematics. This is an excerpt from Wikipedia, the definition of alpha compositing. Because as we know, each pixel can be represented by a vector of the red pixel, the red channel, green channel, and blue channel. Each of the channel it's a integer from 0 to 255. So if the input pixel multiplied by 1 minus alpha, which alpha is the transparency metric from 0 to 1, it's a float, and plus by alpha multiplied by the logo pixel, we then get the output of the pixels. So the proposed method number 1 is pre-distortion. Actually, the pre-distortion method is borrowed from the telecommunication industry, because in telecommunication industry, they have to improve the linearity of the radio transmitter amplifiers. So they have to calculate what has to be done before actually transmit to keep a good performance. So let's see the left. The P is the original pixel, the vector of RGB, and alpha is the transparency metric. So we get the equation, the sub P is the pre-distorted pixel. So let us to improve this, to prove this when the sub P is watermarked later. Remember the equation? We can multiply it by 1 minus alpha plus the logo multiplied by alpha, which equals to P. This is pretty simple. And we want to give the lossless limitation because each of the pixels must run from 0 to 255. And the alpha should be between 0 to 1. So given a alpha and the x, the pixel must be between this. And we want to visualize it. So the horizontal axis is the original pixel. And the vertical axis is the logo pixel. If alpha is 0, which is totally transparent, the area means the recoverable color area. So if it's totally transparent, you can actually place any the original pixel out of it, right? So this is 100% recoverable. Then when the alpha goes up, the recoverable area goes smaller and smaller and smaller. When the alpha goes to about 0.99 or to totally opaque, then the window closes. There's nothing we can do. It's pretty straightforward, right? So this is the estimation of method number 1. Then we will give the method number 2 to post-process, which means after we get the video, we can simply replace the original pixel with the recovered one. This is a watermarked pixel. This is P, right? And the P0 is original one. So we simply can solve the equation to get P0. And this method actually has no limit at all. the only limitation, in my opinion, is the quantitative loss from the integer to float, then to integer again. So this idea is actually intuitive, but we have facing so much engineering challenges, including one, the extraction of the transparent watermark, how to do a high precise extraction of the transparent watermark, and then how to use the maximum capability of the theoretical recovery range. And we want to do the position fine-tuning and handling the shadow and edge and manage the color space, including the sRGB and linear RGB, and handle the gamma correction, and to integrate a real-time performance framework. So we'll take one step by one step. The first one is to extract the logo. If you are lucky enough, you can simply dive into the package of your software. You can, for example, you can find this one. It's totally high precision. But if you couldn't find this one, you can wait until you get one of the logo with a pure colored scene. Remember the equation, the Y is the composited pixel, and the X, in this case, is the background pixel, which we now know is black, is 0, 0, 0. And the L is the logo pixel. We can, this is equations 1. Then we will wait for another scene. And if it is totally white, we can get another equation. Then we can solve the alpha channel from these two equations. Let me give you a demo. This is a snapshot from my iPhone. We wait for a black one, we wait for a white one, so we get the transparent one, the PNG. Actually, it's interesting to be noted that actually are two different parts which has two different alpha values. The triangle is, the transparency is 0.88. And the other part is 0.4. I think we will talk about later because it is a very tricky method as a countermeasure. After that, we think it's very easy to do automation because as a content provider, you can simply inject those two frames into your streaming. And two of any pure color scenes are fine, I think. Then a simple automation script should do well. Or if you really get sufficient fans, you can deploy an advertisement to do this. And there are other potential methods for extracting, like you can do estimation with AI, or you can set up a long exposure algorithm because all the other time varying parts will be averaged. Then we start to do some statics experiments just to prove our concepts. I want to share some effective approach during the development because as we know, the challenges in image and video processing they are not so easy to develop and it's very hard to debug. So we start by writing Python scripts as a prototype. We can tune our algorithm, we can tune the media sources, and we can tune the color, we can tune the position. And you can find the test case here. And then we start writing serious C++ code with highlight. And in this approach, we can improve the performance, and we can integrate it with FFmpeg for real-time processing, and we can use our Python code as a test case, I think. So Highlight is a project published by MIT back in 2013. In my opinion, it's a quite simple, quite effective way, and is similar to TensorFlow and to GNU Radio, the swig of GNU Radio, because it includes the glue language to glue all the other computational modules together. And actually in Apache MXNet, it has already used highlight as a IR. During our experiment, I think it has gained enough performance simply by using its native scheduler and leave us with enough space for future optimization. So demo time. The first one is the original image, and this one is the normally watermarked picture. And this is a pre-distorted version before uploading. Then this picture gets watermarked again. We get this. As you can see, it's totally cancelled. This is the method number 1. And the post method is as good as the first one, I think, in this case. Actually, this is a very lucky case. I will explain later. And we'll show the other one is not so lucky case. Because you can see this is a pre-distorted algorithm. I think the algorithm has been doing a very hard work because this is so hard that nearly out of the range of the pixel. So this one, the I part has some not so good result. However, the post method is very good. So we tried with the Skype logo, the pre-distorted version, and the method number 1, the cancelled. Actually, if you can see, there's some GM trace in here, right? And the post method is very good, as always. Actually, this is not lucky case. So here, you can see the hair part. You can see some watermark still, but it's better than this one, right? This is the original watermark picture, and this is a solid post method. This, I think, is a lucky zone. Let us find it out why it's lucky. So then we want to integrate our codes into a real-time processing framework. We use FFmpeg. This is our system architecture. So first we extract the high precision logo from 2 still images with solid color background. Then we get a logo with alpha channel. After that, we write a FFmpeg filter with highlight support, and we input those 2 files to FFmpeg. Then it handles all the real-time scheduler, handles the video streaming protocol, RTMP, and after that we also build up a simple demo live streaming services using Nginx. The module Nginx-RTMP- module is quite simple and easy to use. And we use OBS to handle all the user interactions during this process. And after a few days coding and building, we released this project called Trademark Block. So you can simply clone the code from github.com/tmblock and configure it, make it. Actually, my co-presenter, he used Arch Linux, so he make a package. You can simply use this line of command to install it. Then run, we have 3 different parameters: the position x, position y, and the function. The function has several options. You can use the first one is a pre method, is method number 1 to pre-distortion. And the post method is number 2, and the embed method is to simply add a watermark. So this is the screenshot from the video processed by our FFmpeg. Actually, you can see the right upper corner is the original watermark, and this one is the pre-distorted version of video. And actually, this one is not very lucky because you can see this part is doing well, and the other parts not so good. And this is a post method, very solid. And this is another example. In this example, it's totally make no sense because it doesn't do anything at all. However, I placed the watermark here. Did you find that? Did you see that? The watermark totally disappeared. Actually, you can still see some watermark in the black area, right? But it's way better from here. It's quite an interesting thing. And the poster method is very, very good as usual, right? This is a picture from Heidelberg in Germany. I can see this one, the sky part is cancelled, but the mountain part didn't cancel. From here, the sky disappeared, mountain remained, totally disappeared in the sky area. So this is the line. You can stick into this part. You can see, wait. Did you see that? I think it's a very interesting thing. Let's see it again. The right part is a post method. This is the original watermark. This is pre-distorted watermark. So from here you can see it's totally cancelled. So why is this? Remember the recoverable range. Let's take an example for when the alpha equals to 0.5 and the watermark, the color is totally white. So the color is 255. So the recoverable range lies here to here. So if this is a whole range of any color, the recoverable range is this large. So I think it's acceptable attack surface, I think. If we add some tolerance by human eyes, we can, like 90% recovery, is got a little bigger. So this is my picture, and the recoverable area lies in here. So which means if you placed a watermark in these areas, it can be actively cancelled at all. Remember this picture? The recoverable area lies here. And this is a bad case because the watermarks can only be placed here, here, and here, and then can be cancelled. This part, the whole sky area can be actively cancelled. So if you are a video originator and you want to protect your pixels from any ugly watermarks later, there is a pro tip which is record under sky. And this is a live demo of, this is a demo about Bilibili. It's one of the biggest video providers in China. And this is still the static experiment. We extracted the logo with high precision. And this is totally, I think it's very good because the logo stays in the lucky zone, remember, this part. So this one is cancelled. And this post method is always good. And this is a web player in the website. So this is the original one. This is a pre-distorted media. When we uploaded it to it, it becomes this. Actually, if you look enough carefully, you can see there is some small problems in the edge because this is a different PNG parsing libraries for edge blurring. So this is it can be used as a countermeasure later. And there are other ways to protect, to attack against the watermarks, such as to transform one watermark into another provider's, or to add some code rate with high frequency components under the watermark area. So the video codec will reduce the code rate near the watermark. Actually, I observed the code rate jitter in the latest World Cup. And for another way, I think is just a frame squeezing, because if you want to place your audio on your blog, you can simply hide this, don't use these pixel areas, and write some JavaScript or iframe to bypass the watermark on your blog. And there is other interesting work I think it's worth mentioning, because someone wrote a fake website to use the CSS rendering time to recover the pixels of the username. So using the different timing, the rendering timing to extract the username, I think is some kind of a side channel. And I think it's an interesting new research surface. So for the evil side, I mean the sites that want to add ugly watermarks, there are some countermeasure to. The first one is to add some blurring edge and to combine transparent part with non-transparent part to make the user thinks this logo is transparent, but actually it has some opaque part. And this part, remember the case we used earlier? It's a quite interesting way to countermeasure, because this part, the alpha is 0.88, and after calculated, we got the recovery range from 204 and 255, and this part is 0 to 153, and the two sets got none element in common. So either you can cancel this part, either you can cancel this part, but you cannot cancel the two parts both at the same time. And other ways, like the traditional dynamic watermark or breathing style, or if we can do a anti-watermark. Actually, this picture is a demo from iPhone using the last watermark. This is the normal one. You can see this is a little black, and this is a pre-distorted one. And after I placed this one into my iPhone, it gets here. You can see this area is totally recovered, but this area cannot be recovered at all. So conclusions, what we have done so far, we have do a theoretical estimation, and with our two methods, we provide a real-time processing framework, and we provide a debug testbed and publish some running code. You can start from here to do your other research. And future work, I think, one is to extract from arbitrary video sequences to get the high precision logo. And with AI, we can do some enhanced image recovery with some fancy model. And we can recover the loss caused by opaque watermarks. And we can, I think this way is quite promising, because if you integrate the whole algorithms into the FPGA of the USB camera, you can do real-time pre-distortion way. I think this is very interesting. On the fly, yeah. Hopefully this work will be able to push the video content providers to stop using those ugly and non-invisible watermarks, and user experience matters. To protect your copyright, either you deploy the modern DRM measures or invisible forensic watermark, or be a man, just release your media under some license, I think. So this basically is a hack of the people, by the people, and for the people, and the watermark shall perish from the earth. Okay, thank you. And questions, welcome.
I have a question.
Mm-hmm.
You said one countermeasure to removing watermarks is to randomize the location.
Mm-hmm.
Have you done any work on detecting a known watermark in different locations and canceling that.
Your question was how to detect the dynamic watermarks in different positions.
Yes.
Well, I think actually there is one way without the solid background is to detect the color range of the watermarked pixel. Because the watermarked pixel, the color range is different from the other.
Yep.
So this is there is a reference you can use from this link. I think this link gives a way of this way to mirror the dynamic watermark simply by detect the range difference. I think.
Very good. Thanks.
Thanks.
I think they also have a black frame between scene changes. That might also give you a clear.
Well, very neat, I think, this idea, because there are transitions from the non-linear. Yeah, I think this is a very neat way.
One other comment was with your camera technique that you talked about, that having a PGA over there. One that is targeted to one particular provider or display network that you are going to upload it to, right?
Mm-hmm.
Again, there is the vendor just needs to change the location a little bit. That will stop your pre-processing work from working. But the post-process works the best. It is more convenient.
Yeah, I think so your question was the post method is more convenient, and the pre method can be when they're using dynamic ones, right? So the post method, I think, will be used largely in the browser or the mobile. We can provide a mobile app to use the post method. I think post method has more affection because it has no limit. I think the earlier one, the other one doesn't use a post method because they don't have the ability to gain the access of the high precision logo. I think the key of this method is to extract the high precision logo with alpha channel.
One other question was, what about color logos, where the channel places their colorful logo, not just alpha, but a proper color logo?
Colorful logo. Actually, this page. Wait. Actually, this page, the vertical axis is only one RGB, the one element. So if you want to do a colorful area, colorful case, I think this is you can stretch it in 3 dimensions. Actually, the reason why I didn't draw the diagram of it because it has to be a heat map. You can imagine. So I only use 1 dimension as a proof. Okay, thank you. Okay, thank you guys.